When it comes to x-intercepts and factors, we need to pay attention to what is called multiplicity. And here's the definition of multiplicity. It says multiplicity is the number of times a factor occurs when a polynomial has been factored. So at a real zero of even multiplicity, the graph of your function is going to touch the x-axis. Now, what do I mean by any of that? Okay, we have this graph over here, and I have this function. You can see I have two examples of touching. On this one here, it comes up, and then it's going to touch that x-axis at x equals -2, and then it's going to touch that x-axis and turn back around. Or on this one here, it starts up above, it's going to come down, it's going to touch this x-axis right here at 3, touch it, and then turn back around. Now, how do we know that these are going to touch? Because we're going to look at that multiplicity. That multiplicity is even. So if that x-intercept here is x equals -2, in factored form, that's x plus 2. And how many times do I have an x plus 2? Well, I have 2 of them, right? We have x plus 2 quantity squared. So because of that squared right there, because we have an even multiplicity, that's what makes this touch. Same thing here. Where is it touching at x equals 3? So in factored form, x equals 3 is x minus 3. And how many times do we have this factor? We have 2 of them. So because we have an even multiplicity of them, that's what makes this touch. Now, when I have an odd multiplicity, which is more times than not what's going to happen, because usually we have one multiplicity of it, the graph of the function crosses the x-axis. Okay, so let's look at this graph again to see what we mean by crosses. We have 2 crosses here. Here it starts up above, it's going to cross at x equals -4, and it's going to cross it and now go down here below. So it started above the x-axis, now it's down below. Here it starts down below the x-axis, then it's going to cross right here at x equals 1, and then now it's up above it. So touch and turn versus crossing through the x-axis. And again, when I look at this function, I can tell that it's going to cross because right here we have x equals -4. And that factored form, that's x plus 4. And if I don't see an exponent here, then there is a little known 1 to be there. So I have one multiplicity of x plus 4. Same thing here, it crosses at x equals 1. In factored form, that's x minus 1. And what is my multiplicity? It's 1 because I only have one of them. I don't have any other exponent. Okay, now this is going to be kind of a homework question, and it is what it is. Form the polynomial whose zeros and degree is given. So I have a 0 at -3 with the multiplicity of 4, have a 0 at 5 with a multiplicity of 1, and the degree is 5. So if I'm forming this polynomial, if I have a 0 at -3, when that's in factored form, that is x plus 3. And it tells me I have a multiplicity of 4, so that means that's my exponent. Now I have a 0 at 5, so in factored form, that is x minus 5. And I have a multiplicity of 1, so we can put a 1 exponent if we want, but not necessary. And then you can just check. Yeah, it should have a degree of 5. Well, I have 4 x's here, 1 x here. Yes, when I multiply that all together, we would end up with an x to the 5th. And so that's all you have to do for that problem there. Now, in example 7, it wants us to find the zeros of the polynomial function and state the multiplicity of each. Then state whether the graph of f of x will touch or cross the x-axis at each 0. So let's just start by first listing our zeros here. I want you to pause this video and see if you can list all 4 zeros. Okay, hopefully you had time to pause it and to try to figure out your zeros. I am sure that we all got this 1 right here, -4 here, and positive 6 here. Okay, you do x minus 1 equals 0, add your 1 over, x minus 4 equals 0, subtract your 4 over, and x minus 6 equals 0 here, and add your 6 over. We are missing 1 if you didn't get this one right here. It has a GCF of 5x to the 4th. Because it has an x in that GCF, that is a 0. If you solve for that, 5x to the 4th equals 0. First thing we would do is divide by 5. We get x to the 4th equals 0. The opposite of the 4th power is the 4th root. And the 4th root of 0 is 0. Okay, so those are our 4 zeros. 0, 1, -4, and 6. Okay, so now let's state their multiplicity, and then we're going to state whether it touches or crosses the x-axis. So when I have a 0 of 0, we had an x to the 4th. So its multiplicity, that exponent, is 4. So because I have an even multiplicity means it touches the x-axis. When I have a 0 of 1, we have a multiplicity of 3. Because my multiplicity is odd, not my 0, I don't care about the 0 being even or odd, but because the multiplicity is odd, odd means it crosses. When I have a 0 at -4, what is your multiplicity here? If you don't see an exponent, that's a known 1. Now this is a good example. I have an odd multiplicity and an even 0. I don't care about even or odd from this 0 here. I'm looking at even or odd from multiplicity. Because I have an odd multiplicity, this crosses. And then lastly, at 6, we have an even multiplicity. It is at 2. Even multiplicity crosses. So I want to make sure we understand it's not because this 0 is even. I'm looking at multiplicity is even, so it touches. Now, as a bonus question here, I want to know what is the degree of f of x and what is the leading coefficient. So if I was to multiply all of this out, which would not be fun, I have 5x to the 4th times x cubed times x squared. Okay, and I think actually those underlines make it even more confusing here. Okay, I have no coefficients in any of these in here. This is 1, or this is 5 times 1 times 1 times 1. So my leading coefficient is going to be a 5. But then I have 4x's here, 3x's here, 1 here, and 2 here. So 4 plus 3 plus 1 plus 2 is going to get me x to the 10th. And then I don't know what happens after that. But the degree of this function is 10. My leading coefficient is that 5 right there. Okay, let's go ahead and continue on. And we're going to go through example 8. And this kind of puts everything together from really this video and last video together in one. So this says, use the graph below of the polynomial function to answer. And I want to know, write the equation of the polynomial, smallest degree possible. So if it is even multiplicity, we're going to put a 2. If it's an odd multiplicity, we're going to put a 1. And then we're going to find the y-intercept. Where is it crossing? I can see it's crossing between 5 and 10, but where specifically is it crossing? Now, I put this table up here for you. It's not really part of the homework, but this is kind of the thought process that you need to be thinking as you write this equation. So the first thing, let's find our zeros. Looks like we have 3 of them. So we've got -4, -2, and 1. -4 right here, -2 here, and 1. Okay, so now let's just stick to 1, 0 at a time. At -4, is this touching or crossing the x-axis? That is crossing the x-axis. If it is crossing, what does that tell me about my multiplicity? Is that going to be even or odd? Well, when it crosses, we have odd multiplicity. So now let's factor this. If I have a 0 at x equals -4, that is x plus 4. And because I want the smallest degree possible, I'm going to keep that as a 1. If it didn't say this, we could say that this was cubed to the 5th, to the 7th, to the 9th, but it was the smallest degree possible, so just to the 1st. Same thing here at 2. At -2, is this crossing or touching? That is crossing. It's crossing through at -2. So again, if it crosses, that means it is odd multiplicity. And so this in factored form would be x plus 2. And then here at 1, does this touch or cross the x-axis? This one touches, does not go through. When it touches, that is even multiplicity. And again, because I want the smallest degree possible, that even is going to be a 2. So in factored form, this is x minus 1 even squared. If it didn't say smallest degree possible, you could do to the 4th, to the 6th, to the 8th, but smallest degree 1s and 2s for that multiplicity. So now write the equation of the polynomial. We have f of x equals, and then I'm just writing these out now. So here we have a 0 at x equals -4, it's crossing through. At -2, crossing through, and at 1, because that even multiplicity, it's touching. Now your homework wants to know what is the y-intercept. And again, we can see it's between 5 and 10, just don't know exactly where. Is it 7.5? Is it 8? Is it 7? We don't know. So to find the y-intercept of this point right here, y-intercepts have an x of 0. So what I am looking for is the y right here. So if I know that my x should be 0, I'm going to substitute in a 0 for all 3 of these x's and then solve. So I have f of 0 equals 0 plus 4, 0 plus 2, and 0 minus 1 squared. So you could really put that in your calculator just like that. But if we evaluate, we have 4 times 2 times -1 squared. Order of operations says parentheses first. Next is exponents. So we would have f of 0 equals 4 times 2 times -1 in parentheses squared is 1. So f of 0 equals 8. So therefore, my y-intercept is at the ordered pair 0, 8.